Good afternoon, everybody. This is Mr. Sadler coming to you live from the internet. Whoops. On Wednesday, April the 29th, 2015, I would like to thank Michael and Mr. Tozer before we begin for any help they can get during today's lesson. If something is not clear today, please raise your hand, and one of those two gentlemen will hit pause in the video and explain to the class the concept that's happening. So thank you very much, guys, before we begin. Today's note is called Increasing and Decreasing Functions. So we're finally beginning to graph, which is very cool. Calculus makes graphing tremendously easy, and we'll go through how to graph all sorts of things during calculus in this unit. Yeah, we haven't had the graph yet in this math course, and we're, what are we, 3 months in? Or we were almost 4 months in, so here we go. We're going to say a function is increasing if it has positive slope. Or f prime of x is greater than 0. A function is decreasing if it has a negative slope. Or f prime of x is less than 0. A function is at a local max or min when f prime of x equals 0. And once again, if I'm going too quickly, somebody raise their hand and pause, and the teacher will pause it. What I'm saying. So we'll just finish the note here, don't do examples for the rest of the class. We'll say, so by taking the first derivative, and solving the inequality, you can find periods of increase and decrease. Which is very, very cool. Okay, the fact we can do this will help to speed our lives up considerably on complicated graphs. All right. So today we're going to start with polynomial graphs, so you guys get the handle of it, and we'll get to more complicated stuff as time goes on. So example 1 is going to say, and again, if you're behind here, somebody raise their hand, and Mr. Tozer or Michael will pause the video. Example 1 says, show using algebra the periods of increase and decrease for f of x equals 4x cubed plus 5x squared minus 2x, and use this to help sketch. Okay, so starting tomorrow, you should have graph paper. I asked you guys to have graph paper already, so if you forgot about it or left it at home, today's very, very soon we're going to be starting to do it. Today we're just doing rough graphs, so I want to get them more interested in the periods of increasing and decreasing than formal graphs. By the time I'm here on Friday, we're doing perfect graphs. All right, so let's get to our solution. Laurel, can you be brave, please, and give me the equation for f prime of x? Good, so 12x squared plus 10x minus 2. All right, so when you are dealing with inequalities and positives and negatives, thinking back to advanced functions, what we would have to do is we'd have to solve the equation 0 equals 12x squared plus 10x minus 2, and then make an interval chart to find out when the graphs were above, when the equation was above or below. So we're doing the same thing right now. The first step that I'm going to do is divide everything by 2 because it's easier that way. So we're going to multiply to negative 6, add to 5, it's going to be 6 and negative 1. So 0 equals 6x squared. Okay, so the roots here for this are going to be x equals negative 1 and positive 1 over 6. So what we're going to use the roots for, those are going to be in between parts. The roots are going to be where the graph is at a local max or local min, so it's neither increasing nor decreasing. So the way our interval chart is going to work we're going to be taking setting this up like we're going to say put f prime of x here, put f of x there, and then we're going to put down test point. Our first interval, and I'm going to make a little chart sort of like this, is going to be to the left of the first root. So we're going to say what happens when x is less than negative 1. Then we're going to have x equals negative 1. Negative 1 is less than x is less than 1/6. Go to the next board. X equals 1/6. You know what, Michael? And you can probably correct me here. I think I did this vertically the other way last year, didn't I? Yes, I did. All right, so class, erase what you just did. Maybe for this one, I'll leave it here. Next time I'll go opposite here because I don't want to take it too wide of the page. Then finally we'll do x is greater than 1/6. I have to do this opposite last year. That's okay. Okay, so what we're just going to do is we're going to pick test points down at the bottom. My test point for x is less than negative 1 is going to be negative 2. I should do this in a different color maybe. A number less than negative 1 is in fact negative 2. A number equal to negative 1 is negative 1. This is going to be 0. This is going to be 1/6. And this is going to be 1. If you were wondering, my f of x equation was equal to 4x cubed plus 5x squared minus 2x plus 1. And f prime of x was equal to 2 times 6x minus 1 and x plus 1. Okay, so what I'm going to do then is I'm going to pick values for f prime of x for my test points. So what I'm going to do is I'm going to do f prime of negative 2. So f prime of negative 2 is going to be negative 12 minus 1, which is a negative, and negative 2 minus 1, which is negative. So a negative times a negative is a positive times 2. So that's going to work out to be positive. Okay, now, somebody raised their hand if they don't know why that's positive, and hopefully one of my helpers will help me out here. What happened was 6 times negative 2 right here is negative 12. Minus 1 is negative 13, so that's negative. Negative 2 minus 1 is also going to be a negative. A positive, a negative, and a negative is going to be a positive. So this one is just going to be for my f of x. This is going to be the shape of the graph. If something has a positive slope, how's it going to look? Well, it's positive, so it's going to look something like this. That's a positive slope. It looks like that. When x equals negative 1, f prime of x is going to be, well, negative 1 plus 1 makes this 0. So this is going to be 0. What that looks like is a nice little point. When x is equal to 0, 6 times 0 is 0 minus 1, making this negative, and 0 plus 1 is positive. A positive times a negative times a positive is going to equal a negative. When x is equal to 1/6, we should get another 0. And when x is greater than 1/6, which is equal to 1, 1 plus 1 is positive, 6 minus 1 is positive. So this is also going to be positive for this one. Okay, I'm probably going to ask the teachers to hit pause and explain because I'm not sure how well that was explained. It's difficult to do by myself because it makes sense to me, but I want to make sure that it does for everyone where those came from. Okay, I'm going to graph now f of x. To help me, I'm going to find what f of negative, so I'm going to find the points when f prime of x equals 0. So I'm going to find f of negative 1, which is going to be 4 times negative 1 cubed plus 5 times negative 1 squared minus 2 times negative 1 plus 1. That's going to be negative 4 plus 5 plus 2 plus 1, which is going to be 4. So my first, I will have a point on the graph, negative 1 and 4. F of 1/6, unfortunately, won't be that easy. So I'm just going to do it. On my trusty rusty calculator. Okay, so I'm going to do 1 divided by 6 cubed. Oops. Bracket. 1 divided by 6 cubed. Fraction here. I don't think we're going to do it. So that's what it is this time. Times 4 plus 5 divided by 36 equals minus 2 divided by 6 equals plus 1. I'm assuming there's a nice fraction, and hopefully you'll find it, but I'm going to use for today, so I want to move on to this quickly. We'll have a point at 1/6 and 0.82 approximately. Okay, so now it's time to graph. So if you can get us some graph paper, please, and we'll actually graph this. I will use my graph paper, which is nice. Okay, so I have to just graph 2 points, which was nice, and I lost my tool. There it is. The nice thing with this, we only have to graph 2 points. Okay, so I'm going to draw this here. I got to get down to negative 1 and positive 1/6 and negative 1. Okay. And I think most things are positive here. All right, so what we're going to do is here's going to be y-axis. There's x, there's 0, 1, 2, 3, 4, 5, 6. So it's going to be 1/6 there, 1/3, and so on. So this is negative 1/6, negative 1/3, negative 1/2, negative 2/3, negative 5/6, negative 1. 7, 6, and so on. I have to get all the way up to 4, it looks like, so I'm going to go, there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, there's 8, there's 9. I got a lot higher than that, but that's okay. Alright, so I'm just going to plot my points on there. I'm going to have a point at negative 1, comma 4, which is going to be up here someplace. I have a point at 1/6 and 0.82, which are going to be down here someplace. Now this is where we're going to go back to our interval chart here, hopefully. Right? And if I'm going to quickly teach you, so you can slow them down. So all I'm saying is, from the left of the board until my point at negative 1 and 4, it should be going upwards, which it does. Okay? Then from negative, when x is negative 1 to positive 1/6, the graph's going to go downwards sort of like this. Okay. And then when x is greater than 1/6, we're going to have a positive slope. And this is a graph of f of x. Okay, so let me just try and explain again one more time. So this right here will be f prime of x is positive. This right here is f prime of x is negative. And this right here again is going to be f prime of x is positive. This graph would be impossible to do in advanced functions. Okay? So in advanced functions, what you would have to do is you get a point at 0 and 1, which would be nice, which would be right here someplace. You'd also get some sort of x-intercept down here someplace that would be very hard to find. Okay, with calculus, this is really, really easy to graph. Right? All right, let's move on to example 2. If we can. This is a little bit different than my note. I'll do example 3 first. Example 2 is going to say the derivative of a function is f prime of x is equal to 3 minus x, 2x plus 1, and x plus 2 squared. We're going to say find the intervals of increase and decrease. And sketch f of x. Now this question is so awesome I can't even believe it. What I'm telling you, I'm not even giving you the original function. I'm giving you its derivative, and I want you to sketch the original function. That is tremendously cool. Okay, what you are going to get from this graph, or from f prime of x, the zeros of that will be your points of local max and local min. Okay, so I'm going to make another interval chart here. I'm going to do this the right way this time, so sorry about that last time. I'm going to make my interval chart is going to be, I should probably find my zeros first, okay? So I'm solving, sorry, I got too excited here. Here we're going to have x equals 3. X equals negative 1/2, and x equals negative 2. Okay, so the way my interval chart's going to go is I'm going to put my intervals down here. So I'm going to say x is less than negative 2, x equals negative 2, negative 2 is less than x is less than negative 1/2, x equals negative 1/2. Negative 1/2 is less than x is less than 3, x is equal to 3, and x is greater than 3. Then I'm going to put f prime of x f of x, and then I'm going to write test point. Okay, so what f of x is just going to give us is sort of the shape of the graph. And we're going to sub in when it equals 0, okay? So right away, when we do this, if I know that when x is equal to -2, that's going to be a 0 there. Okay, the reason I know that, I'll put my test points in here first. Let's go for -3, -2, -1, -1/2, 0, 3, and 4. These can be any points within those intervals, okay? I know that the zeros are going to come in here because right away on the left-hand border, those are my 3 zeros. All we're going to do is to check the other things that are in there. So f of x here is going to be a point right there. I should probably work those out, and actually I don't actually have to what the points are, but eventually I will do that. When x is less than -2, okay? So if I pick -3, 3 minus -3 is a plus. 2 times -3 is -6 minus 1 is a negative, so positive and negative, and -3 plus 2 squared. -3 plus 2 is -1 squared is a positive, so I think I ended up with a negative here. Let's put a negative. And a negative slope looks something like this. Okay. From -2 to that, so I'm going to use -1. 3 minus -1 is going to be positive. 2 times -1 plus 1 is going to be negative. And -1 plus 2 squared is going to be positive. So it looks like to me again I have another negative, which is interesting. 0 is going to be between -1/2 and 3. So 3 minus 0 is a positive. 0 plus 1 is a positive. And 0 plus 2 is a positive. So this one's finally going to be positive. Something like this. And x is greater than 3, I'll pick 4. 3 minus 4 is a negative. 6 plus 1 is a negative. So it's positive, negative, positive, and positive. So this is going to be negative. Okay, now I'm going to get the supply teacher or Michael to hit pause on the video and ask if there's a question with this, because this table is sort of really important. So I need to make sure that this is good before we continue. All right, now the difficulty of this question is I don't actually have points for x and y. So this is just going to be a rough sketch that we're going to do today. The key points that I'm going to use, though, so there's my point, there's my x and there's my y. I have no idea how high or how low this graph is. All that I can do for this one is sort of estimate. I know the shape of what the graph's going to look like, but I'm not actually going to know what it is. So the key points are going to be important to me are going to be there's 1, there's 2, -1, -2, 0, 1, 2, 3. The points that are going to sort of be key are at -2, because something special happens there. -1/2, something sort of special happens there. And 3, something sort of special happens there. Okay, that's the points where there's a max or a min. So it says when x is less than -2, I'm going to pick a point right here. It doesn't matter where it is. I'm going to say it has to be a negative slope heading into that. So there it is. Then from -2 to 0, it has to have another negative slope. So I'm going to draw another point down here, someplace. And I'm just going to go sort of like this. We don't know how that line's going to look exactly, but that's just an estimate for me. From 0 to 3, it's going to be positive slope, so I'm going to pick another point over here. I'm sort of going to curve up sort of like this. And finally, when x is bigger than 3, it's going to drop down, sort of like that. Now, these are all estimates. These graphs, the points could be not anywhere near the x-axis, but the idea of the slope, what I'm looking for in this question is for each interval to have the correct slope. So this, again, is a negative slope. This is a negative slope. This is a positive slope. And that's a negative slope. Okay. All right, how are we doing for time? Yeah, 25 minutes. Maybe I'll do one more here. Maybe I'll do a word problem one, and then I'll give you guys a chance to. All right, example 3. This is going to be the last one here. Example 3 says a box is to be constructed from a rectangular piece of cardboard sorry. That measures 12 centimeters by 8 centimeters. Sorry, 12 by 18 centimeters. Equal squares of length x. Are to be cut from the corners and the 4 sides folded up. Okay, letter A is going to say, find the volume of this box. Find an expression for volume. Now, probably the teacher will need to hit pause at this moment to make sure that everyone has that scribbled down. If anyone's ever scrunched up a box, this is what this is going to look like. You're starting with a 12 by 18 rectangle. When you actually make a box, what is actually going to happen though is you're going to cut out 4 sides like this, each of length x. And then this side will fold up like that. So the way we're going to do this here, we have to get an expression for length and width and height. Okay. It looks to me like the height of the box is going to be x. Because you fold any of those corners, they're all going to be x. Let's call this the width. What's this distance right here going to be? Well, I'm going to call that 12 minus 2x. If the entire thing's 12 and there's an x on each side. The length I'm going to call this. And I'm going to call that 18 minus 2x. So my expression for volume is equal to x times 12 minus 2x times 18 minus 2x. Let's go crazy and FOIL that out. Okay, so that's going to be 12x minus 2x squared times 18 minus 2x. When I FOIL that out, I get, oh boy, 12 times 12 is 144. Let's check that so I don't make another mistake. Why does my calculator disappear? All right, so we'll do 12 times 18, which happens to be 216x, minus 24x squared, minus 36x squared, plus 4x cubed. So the volume is equal to, sorry, v of x, should I call it? 4x cubed minus 60x squared plus 216x. All right, so there's our volume. Part B is going to say, and this, I'm going to start with you on this question because you asked for this earlier. Part B is going to ask, what is the domain of this function? What x values will work according to that picture? Now I'm going to say my domain is going to be x has to be greater than or equal to 0. I guess technically, if something has a 0 height, it'll have 0 volume, but that's okay. We can deal with that. Okay, letter C is going to say determine the intervals of increase make an interval chart to determine the intervals of increase and decrease for v of x. Okay, now Mr. Tozer and Michael, if you can hit pause in the video right now, I'd like you guys to find the first derivative. Then what you should do is solve v prime of x equal to 0, get your roots for that, and then we'll make an interval chart to find out when this graph is increasing and decreasing. Okay, so I'm going to do this in green. I'm going to start with v prime of x should equal 12x squared minus 120x plus 216. I think you can factor out a 4 there, I think. 3 times 4 is that 54? Oh, I can take out another 3. Sorry about that. So v prime of x is equal to 12 bracket x squared minus 10x plus I think 18 times 3 is 54, is that right? Is that right? Actually, let me check my notes. So I'm trying to get this from my head. We all know what happens when Mr. Sadler tries to calculate this, and it doesn't quite work. Okay, that works. So we're trying to solve this equation then 0 equals x squared minus 10x plus 18. I want to be able to factor this one. You want to be able to factor this one. Unfortunately, we cannot. So I'm going to unfortunately use the quadratic formula and say x is equal to 10 plus or minus the square root of negative 10 squared negative 4, 1, 18. All over 2 times 1. I'm going to do this very, very quickly because I know you guys are all masters of the quadratic formula. And I get x equals 7.65 or x equals 2.35. Now I should have maybe fixed up the domain. Okay, so my domain's actually wrong. I should actually pay attention when I'm teaching here. What's the biggest? X is not just bigger than 0. Let's go back to our diagram here. What's the biggest possible value of x? Good, it has to be between 0 and 6. The reason for that once you get a value of x to be 6 on the right-hand side here, you have 6 at the bottom, 6 at the top, that makes 12. Okay, so the reason that's important here is because now this value is going to get ignored. And we're just going to use, because we're just using from 0 to 6. So there's one mistake today. Sorry, Michael. All right, so let's do our interval chart here right now. We're going to say our intervals, we're going to say 0 is less than or equal to x is less than 2.35, x equals 2.35, 2.35 is less than x is less than 6, and that's it. We're going to say f prime of x, and then we're going to have the f of x shape, and then we're going to have the test point. Okay, so when x equals 2.35, f prime of x is going to be 0, and that's going to be a plus, so this is 2.35. When you have an f prime of x equals 0, what does that tell you about x equals 2.35? So when x equals 2.35, the volume is at a max. Which is nice. I'm going to pick a value here of 1, and I'm going to pick a value here of 3. Going back to my equation here, I guess these are all equivalent. I'm going to use this one right here as the one I'm going to sub into. Okay? So 1 squared is 1. 1 minus 10 is negative 9. Negative 9 plus 18 is positive, and a positive and a positive is going to be positive, meaning that, so that means from 0 to 2.35 centimeters, the volume is increasing. Okay, and I'm going to pick the value of 3. I'm going to sub that into here one more time. 3 squared is 9. 10 times 3 is 30, so 9 minus 30 is negative 21. Negative 21 plus 18 is negative 3. 12 times negative 3 is a negative number. And we're going to say from 2.35 to 6, the volume is decreasing. Now this is nice for us. Now you guys are saying, yeah, whatever, Mr. Sadler, this interval chart looks to be a pain. But see, the nice thing about this is helps us to solve cubics here. We started off with a, messy cubic right there. Okay, we were very, very easily able to find the local max, and that's nice. Okay, when's this graph increasing, when's it decreasing? That's very cool. All right, so that's why I teach math. Your homework for tonight is page 157, number 8, 9, 10, 13, 14, 16. Okay, and I will see you guys on Friday and tomorrow in video form.